Today we're doing combinations. Combinations. So what we're interested in a combination is order is not important. We don't care about the order, right? Permutations, order is important, right? But in combinations it's not. There's still no repetition, like all of those. So what's the difference? Well, here they say, let's pick 3 letters out of a group of 5 letters. Okay? So if we look at, whoa. If we look at this, 3 letters out of a group of 5 letters. Now then, I could choose A, B, and C, or I could choose A, C, and D, or I could choose C, D, and E. See, these are just the groups of letters, 3 letters at a time, right? We're not putting them in order, right? Because if I had ABC, I could also have CBA or BAC or CAB, right? But those aren't in this list because the order that we put them in is not in there. It's just choosing the different sets of letters. So permutation would put them all in order. It would choose them all and put them all in order. So permutation is bigger than combination. A combination just chooses how many ways can I pick 3 different letters. And then if there's 3 letters, 3 factorial is how many ways I can order those letters. So 3 factorial times the number of combinations equals the number of permutations. This is always true. Always true. Right? So let's see if we can find one that makes sense. Okay, here we go. The ski club has 80 members, 50 men and 30 women. A planning committee consists of 5 and 3, right? Now a committee, it doesn't matter what order they're in, right? So we have to choose the 5 men separately. So that would be 50 out of 5. And then the 3 women also chose separately. 30 choose 3. Now then, in this book, this is the way they write combinations. It looks like a fraction without the fraction. It just has parentheses around the number. But this is NCR. In our calculator, this is NCR. So what are we doing here? We have 50 numbers, and we're choosing 5 of them. And we're multiplying that times 30 numbers, choosing 5 of them. So let's just look at it the way we would write it in our calculator. If I was doing this, I would have 50, and then C, and then 5. And then multiply times 30, and then C, and then 3. Why am I doing that? Because I'm picking 5 men for the committee and 3 women for the committee. It doesn't matter what order they're in. It doesn't make any difference at all. So let's see. What is 50? Now I go to math, go over to probability, down to 3. 50 choose 5. Look at how many ways there are to choose 5 guys out of 50 to choose from, right? That's 2 million ways, right? Can you see that? There we go. Let's do 30. Math 3. Oops. I forgot to put the 3 there. There we go. 4,060 ways, right? So I have to multiply those 2 numbers together to get the answer. And if you look at the answer that they came up with, this is 10 to the 9th power. That's 8 billion. 8,602,000,000, right? That's what that number is. 8,602,000,000. Whenever you multiply it all out, that's what we came up with. Here it is written down here. 8,602,165,600 different committees that I could choose, right? Different committees. That's what we're dealing with. Whenever we're working with NCR, order is not important. Let's look at another one. Order is not important. So let me erase that. Okay. How about this guy? The high school band has been rehearsing 7 pieces, and the band director needs to select 2 of them for an audition tape. So, what is he going to do? He's got 7. It doesn't matter what order he picks them in. He's got 7, and he wants to choose 2. So 7 choose 2. If you work it out on your calculator, go ahead. 7 choose 2. Math over down to, that's only 21. 21! So there's 21 different tapes that he could make. And that's not putting order in the tape. It's just the 2 songs that he could choose. He could choose 21 different ways to choose 2 songs. How about this? At a family party, 18 people need to be seated at 2 tables. A table for 8 and a table for 10. How many ways can the assignments be made? Well, there's 18 people to choose from. And we're choosing who sits at the first table. Well, let's say who sits at this table. Right? So there's this many ways to choose who sits at the table for 10. Now then, once we choose that, the other table's already chosen because the people left over get to sit at the other table. We're not putting them in order. We're just picking how many ways can I put these numbers, can I pick these people to sit at the table. So 18 choose 10. If you do that in your calculator, that's 43,758 ways. 758. Amazing, huh? How about this one? There's 2 stores that sell pizza, Armando's and Reggio's. And 3 topping pizzas out of a choice of 9, right? So 3 toppings out of a choice of 9. Remember, when you put toppings on your pizza, it doesn't matter which one you put on first. You can put pepperoni, then olives, then anchovies, all right? Or you could put anchovies first, and then olives, and then the pepperoni. It doesn't matter what order they're in, right? So if there are 9, and you're picking 3, how many different pizzas could they make at Reggio's? Reggio's. And then Armando says he's only got 8 different toppings. I guess he doesn't have anchovies. But there he's offering his 4. 8 choose 4. So the question is, which one has a greater number of pizzas possible? Well, you just have to figure out what's 9 choose 3. So do it in your calculator, see what you get. And then what's 8 choose 4? So remember, the way that you do that is you type in 8, then you go to math, then you go over to NCR, and then you put 4. And see, it comes out to be 70. So Armando's pizza, there's 70 different ones here. What about this one? 9 choose 3. 84. 84 different pieces. Ta-da. That's that. Let's look at the last one. Lorna needs to pack 5 blouses and 5 pairs of slacks for vacation. And she's got 14 blouses to choose from and 8 pairs of slacks to choose from. So she wants to pick, to go to the trip, how many ways can she pack her suitcase? Well, you have to keep the numbers together. So 14C5, because blouses, there's 14 blouses and she's packing 5 of them. And then 8 total pairs of slacks, and she's packing 4 of them. So there's this many ways to choose the pants that she wears, and this many ways to choose the shirts that she wears, and you multiply those two together, and that'll tell you how many ways she can pack her suitcase. How many ways? And it's a huge number. So if you got this number, 140,140, you did it right. Hey! That is combinations. See ya.